So today I'm going to be taking you through how to set up our structures product. This one is our shear force demonstrating kit, and it teaches everything you need to know about how shear force is applied and the theory of it in engineering. So the products all come in this format, which is portable and easy to move around from classroom to classroom, but I'll show you how to quickly set it up into the using mode. So there are some fun knots on the top and the bottom that you can twist on and off to take the protective case off. You can either put that to one side or clip it onto the back later for silver storage. I'll put it down here for now. The next is we take the legs off. So on the back, I have some quick release swirl latches here that I can snap on and off with one thumb. And I can twist around, lift up, and insert them into one side, and I can repeat on this side. That's the product ready to go. We have a couple of choices. We can use this product with a laptop software for data acquisition, or by itself and use the digital readout here for more manual mode if you didn't want to have laptops and computers in your workspace. I'm going to show it with the software today. So I'm going to take my USB cable, connect it into here, and that is everything you need to do to power on the product. You'll see that the screen should come on, say Matrix TSL, go through some colors, and once it settles to a green value like it has here, we are ready to go. The next stage is in the kit, you'll be provided with some weight hangers. These are like standard weight hangers where you have individual weights of 20 gram values, and they add up to a 500 gram weight. In different worksheets, you can apply the load on these hanging points, and that's the principle of how structures works. Here I'm going to set up an example of worksheet 4, which is for a UDL type load, which is slightly different application, where we take a single load and we use these square holes and apply them along this section like this. So here on worksheet 4, I followed the diagram and I've applied my weights in the same manner that the worksheet's asking for. With the UDLs, we have these little square holes which allow you to line up weights in this particular manner, and I've done it on the overhang side of the pivot on this side to show a hogging effect in the middle for the beam, which should give me a result for the shear force. So on the software, what I'll be doing is I need to turn on the software in the top left hand corner with a little play button. This will start. It will recognize that this device has what we call one node, i.e. one display. Different products in the range in structures have different amount of screens, and that is represented with the nodes. So you can see that it's appropriate for the one that it's reading. What I then have a choice of is different experiments on the side. So on the far right hand side here, the properties pane, I can pick the experiment that I am working on. So I will find the shear force experiment here, which just configures the display of the graphs appropriate for the product that is being used. On here, I have a choice of whether I want to apply a time-based output. So as time just goes along, a piece of data is sent to the software regularly. I think in this case it's 1 second, as I've set that up here, and it will just keep displaying the same number because I am not changing anything. If I was to wiggle or change the load, the response would be instantaneous. For the worksheet 4 though, I will be changing the amount of weight. So it's the third option down here. In the properties pane, I can choose the load that I'm applying. So this UDL is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 220 grams across this section. I can apply that as a singular load. So that's 220 grams. And as you do experiment, you'll understand that it amalgamates to the middle. So I can apply that UDL of 220 in this example. Here, grams can be chosen. I'll click log. The display of the graph will start to appear. Now what I'll also do is actually remove all of these values. And the result should go back to nearly zero because I've removed all the weights. There's no shear force applied. If I was to change my load of mass back to zero as my original point, I can log that, and now I get a straight line between the 0 point and the 220 point. I could go further with weights or apply more and log appropriately as I want. That's worksheet 4 for you, and this is the shear force.